Shalom to you and welcome. In this video, we will be looking at applications of differentiation in the business and economic world. We have done geometry of optimization. So this is a kind of optimization, how it is used in business and economic world. They have a good summary of the terminologies and formulas that are used for business and economic applications in your textbook, page 228. I encourage you to copy those summary into your note. You will need them. Okay. So a few things you need to know. What a total cost is. I mean, from their name, this is what you do day to day. Cost, whatever you spend. Okay, total cost is the amount that has been paid or given up in order to get something. So when you go to buy an item, you pay for it. So that's a cost. All the expenses you make, buying your shoes, clothes, okay, those are costs. So it could also be effort, whether material resources in time you give up, if you equate them to money, okay, or even risk incurred, opportunities you could have, but you give that up to, in production of good or delivery, charity. If you equate those in money terms, it's going to be considered a cost. It took something out of you. Another term is total revenue. Now, revenue is total receipts, what you receive. Now, cost is what you give up. Now, revenue is what you received. So, all the total income, something that come in. So, we get that by multiplying the quantity of item you sell times the price of one item. The next is the total profit. To know how much you actually gained, you're going to take the total revenue and subtract the total cost to know actually your total, what we call net revenue, what is left after the cost has been subtracted or deducted. So how you know whether or not a business is progressing is by checking their total profit, and it is from this total profit that they use to compute the tax and determine how much of the dividend to pay to any shareholder that is in the business. And you find the total cost again by taking all your total revenue and subtracting the total expenses, the cost. Okay, so now we're going to look at a problem. This is the number one problem in your worksheet, exact same problem. A company has started selling a new type of smartphone at the price of 160 minus 0.1x, where x is the number of smartphones manufactured per day. The parts for each smartphone cost $7. So this is the part for making one phone. It will take $70 to buy the materials you need to make one phone. And then the labor that is involved in making it and running the plant and everything is add up to be $500,000 for one day. How many smartphones should a company manufacture and sell per day to maximize the profit? Okay, so we need to know down here what we are maximizing, the profit. So we need to find the maximum. We need the formula, the equation for profit, which we are going to take the derivative of, okay, and then find the maximum. Remember how it goes. Okay, let's solve it. Okay, so here's the question. We let x be the number of items manufactured per day, which is the number of smartphones for this question. So we need to maximize the profit. We need to maximize the profit. Therefore, we need the profit formula. So profit, which we write as capital P, is equal to revenue minus cost. So that's the base. So we need to find the revenue first and then find the cost to plug them into this formula. So let's leave that there and then find the revenue. So revenue is quantity times price. Quantity times price. Price is small p. Profit is capital P. Price is small p. So, and because we have the quantity, X is the quantity of items produced per day, we want to keep the quantity as X. So that's how much that is produced per day. So that's the quantity. So our R is going to be X times the price. P is how much, and here they gave us the price. They gave us the price. They gave us the price. So they already put it in equation form for us. Put that up. So that's easy. So we plug it in here. 160 minus 0.1x, and this is multiplied by the quantity. So we can go ahead and multiply that to get our R. So we can distribute this 160x, and we can distribute that minus 0.1x squared. So this becomes our revenue, the total income. So we take that total income, plug it into this equation. We write P equals the revenue, which is 160x minus 0.1x squared. And then we're going to do minus. We need to find the cost. Okay, what is the cost? We go back to the problem. Any expenses that is made in the production, the parts for each smartphone. Every smartphone, it costs $70 to make one smartphone. So since X represents the number of one smartphone per day, we can make it 70X for one smartphone. If it's 2, you multiply, X becomes 2. If it's 3, you multiply by 3. 4, you multiply by 4. No, the number of smartphones that is made, you multiply by 70. So we are going to write it as 70X. The number of smartphones that is produced, there is 70X, where X can be any number of smartphones. And another expenses that is made, the labor and overhead running of the plant is $5,000 per day. So that's another cost. So we're going to add it on to 5,000. So this becomes the total cost because there's no other expenses. That's all all the expenses that is made. So we take that and we substitute it under cost. Okay, I don't have enough room here, but it's 70X plus 5,000. Okay, that's it. That's it. So we have our formula. Now we need to simplify it a little bit before we take the derivative. Okay, so we can rewrite this as P160x minus 0.1x squared. Then this becomes minus 70x, and this is minus. This becomes minus because it's negative. One negative here distribute minus 5,000. Okay, we collect like terms. These two have X in them. They are like terms, so we can put them together. So that's 160. Okay, 160 is going to be minus 70. 160 minus 70 is 90. So we have 90x. So this is by itself, and that's by itself. So that's minus 5,000 minus 0.1 x squared. Actually, let's write it in standard form by making this come forward. So P is equal to 0.1 x squared plus 90x minus 5,000. Okay, now we have a better equation. So it is simplified. Now we can take the derivative. So P prime, okay, 2 times 0.1, okay, that gives us 0.2x and plus 90, and this becomes 0. So now that we have the derivative, we set it equal to 0 to find the critical value or the maximum. So this is a linear equation, so that makes it easier because we can subtract 90 from both sides. So negative 90 equals 0.2x. And next, we divide both sides by 0.2. All right, here I'm looking at this. It's going to be negative, which is not right because the money, it has to be, profit, gain, total profit has to be positive. So let's go back and see if we, here this is negative and I wrote it positive here, so that's negative 0.1, so that would be negative 2, is it negative 0.2, so that's negative. So we are dividing by negative actually, so that makes sense. So it's going to be negative 90 divided by negative 0.2. Okay, that gives us 450. So that's 450 is equal to x. And what does x represent? X represents the number of smartphones produced per day. So every day, to maximize the profit, they have to make 450 smartphones and sell 450 smartphones that day. So they manufacture that and sell. Okay, you can go ahead and test this number to make sure that it is maximum, that it is not minimum. So if we take 450 and test it, now we have to have a restriction. What is the restriction here? Well, what could x be and what can't it be? Since x is the number of items manufactured, it can be negative, because if it is negative, it doesn't make sense. So it has to be 0. Either they did not manufacture anything, which will become 0. So 0 is less than or equal to x, which is less than or equal to, well, is there any limit to the number of items they could produce in a day? No, they can produce as much as they want. But we are trying to find the maximum of number they would produce and sell to maximize their profit. So this goes to between 0 and infinity. So we can test any number that is between 0 and 450. Okay, we're using our derivative formula, which will be this one, derivative function. Okay, so if we try that, take any number between 0 and 450 and then between 450 and infinity and test them, you will see that this would actually be a maximum. Okay.